warm greetings to the respected judges and to all who watch this video. I feel glad to take part in RECode contest conducted by the coding club of PSG Tech. It's my pleasure to introduce myself to you. I am Merlin, first year student from ITG1. First of all, I thank you for this opportunity. Let's get into the video. I have taken a problem statement from HackerRank. It is the sum of digits of 5-digit number. The problem is nothing but in a given 5-digit number, we have to take and add each digit of that number to get the sum. Before we write a code for something, a question arises. Why should we do it and what is its application? Here, with the help of the problem which I have taken, we can find the divisibility of a number if some condition is applied. This picture I have taken from HackerRank site. They have given all the instructions which we are going to follow in the code. So let's see them individually in the upcoming slides. The objective given is the modulo operator percentage returns the remainder of a division. For example, 4 modulo 3 is equal to 1 and 12 modulo 10 is equal to 2. The ordinary division operator slash returns a truncated integer value when performed on integers. In manual division, we use only a single operator to perform division. But in coding part, we use two operators. One is to find remainder and the other is to find quotient. So, modulo operator, which is a percentage symbol, it is used to return the remainder of a division. For example, they have given 4 modulo 3 is equal to 1. When 4 is divided by 3, we get 1 as a remainder. And 12 modulo 10 is equal to 2. When 12 is divided by 10, we get remainder as 2. The ordinary division operator is nothing but the slash which we use for performing manual division. Here 5 slash 3 is equal to 1. When 5 is divided by 3, we get quotient as 1. So in a programming side, we use two operators. One is modulo and other to get the remainder and the other is slash to get the quotient. Final statement given to us is to get the last digit of a number in base 10, use 10 as the modulo divisor. It's nothing but a clue to do our code. They say us that if we use modulo 10 to divide the given 5-digit number, we get each digit of a number so that we could add it to find the sum. So we can see this in detail in a while. It's just a clue for our code. The task for us is given a 5-digit integer, print the sum of its digits. So they have given a 5-digit number. We should take each digit and add the digits to find the sum and print it. Okay, this is the task given to us. Input format. The input contains a single 5-digit number n. So the input is nothing but the number that we give to find the sum of digits. So the 5-digit number is called as input, which is denoted by a variable n, small n. The constraint given is n should take the value which is greater than or equal to 10,000 and less than or equal to 99,999. It should not exceed this value. The output format is print the sum of the digits of the 5-digit number. So we should get an input from the user which is a 5-digit number, and we should take each digit and add to find the sum and display it in the output. The sample input they have given is 10,564 and the sample output is 16, which is nothing but the sum of digits. 1 plus 0 plus 5 plus 6 plus 4 gives 16. So input is a 5-digit number. We are adding the digits to get the sum, and the sum is 16, which is returned in the output screen. Let's try this. Before getting into it, let's see an algorithm. Algorithm is nothing but a step-by-step process to solve a problem. So algorithm is written in a simple English to understand the working of a code. So let's get into an algorithm. Step 1 is nothing but start. It's just a beginning. Step 2, initialize a variable sum is equal to 0 to count the sum of all digits of n. So a variable sum is initialized to 0, which is going to store the value of sum, that is sum of digits. So n is nothing but the number, 5-digit number which we give. So the digits of n is added and gets stored in sum. So initially sum has no value, so it is initialized to 0. Step 3. Start a while loop with the condition that n greater than 0. So we are using while loop to perform the process repeatedly by writing the code once. So loop concept is used to perform the process n number of times by writing a code just once. So we are placing a condition that n is greater than 0. When n is greater than 0, the process is repeated until the condition becomes false. Step 4. Add to sum the value at ones place in n as sum is equal to sum plus n modulo 10. Here n modulo 10 represents the value of the digit at the ones place in n. So when we take a 5-digit number, we should take number from ones place, that is the last digit. We should take each number and add to find the sum. So to retrieve the last digit, that is the ones place number, we use this sum is equal to sum plus n modulo 10. When we perform this process, we get the ones place number digit, so that we could take each digit likewise and add to get the sum. So we are using this statement. N modulo 10 is used over here to get the final digit of a number. Step 5. Divide n by 10 as the current digit at ones place has been counted. So when we take a 5-digit number and take the last digit and add it to some variable, now next we should take the next to last digit, that is the tens place number. So to retrieve that number, we should make the 5-digit number into 4-digit. To make it easier, we are using a division operation. That is n by 10 gives us the quotient, which makes a 5-digit number into 4-digit, so that it is easy to take the last digit of a 4-digit number to add it to find the sum. Step 6 is nothing but stop, the end of the process. It's just an idea to know how the code works. Now let's get into the code to know better. Here is the code from which we are going to get the sum of digits of a 5-digit number. This I have typed in HackerRank and taken a picture of it. I'll just explain it. The first 4 statements, that is hash include stdio.h, hash include string.h, hash include math.h, hash include stdlib.h. These 4 are called header files. They are nothing but the text files that contain some code, piece of code. In this program, we are going to make use of only one header file, that is hash include stdio.h. Next comes int main function. It is nothing but the entry point where the compiler begins its execution. After int main, we open a curly braces to write the content, that is body of the main function is within the curly braces. So we have declared a data type int and 2 variables n and sum, where sum is initialized to 0. So n and sum are called variables which contain value of integer type. So we are giving int n comma sum, and sum is initialized to 0. Sum is a variable which is going to store the sum of digits of a 5-digit number. So initially it has 0, later it gets added up. Next comes scanf statement. Scanf is used to get the input from the user. So we are using %d, which is nothing but a format specifier which denotes integer value. So scanf, we are going to get an integer value from the user, and that value gets stored in n. We are using ampersand n, and that 5-digit number which user going to enter is stored in a variable n. Okay, all these statements ends with a semicolon, which is mandatory. It follows the syntax. As I told earlier, hash include stdio.h. Why it is used is, how do the compiler know? If we use printf, it should display the value in the screen, and how does it know? If we use scanf, it should get the input from the user. So there is a code behind everything. Even for printf, there is a code behind it, so that it is displaying the value in the output screen. Even for scanf there is a piece of code. So all this code is included in the header file. So when we use the header file, we don't want to type the code for printf and scanf separately. We can use the header file so that we could use the functions easily, printf, scanf, those words, so that it does its action by itself. Next comes while, which is nothing but a loop concept where we use a piece of code n number of times until a particular condition is satisfied. Here we are giving a condition like while n greater than 0. If n is not greater than 0, the condition becomes false and the compiler comes out of the while loop. Until that, the two statements inside the while loop gets executed. Here we have given sum is equal to sum plus n modulo 10. N is equal to n/10. I'll explain the while loop shortly. Next comes printf statement. It's used to display something in the output screen. Here they have used format specifier, that is %d. So we are going to print a value in the output screen. That value is nothing but sum. We have given %d comma sum. So sum is nothing but it stores the value of sum of digits of a 5-digit number, and that value gets printed. As it is an integer, we are using to denote it by a %d format specifier. Return 0 is nothing but the termination. Whenever we use int main function, we have to end it with a return statement, and here we have used return 0. Finally, we are closing the code with a close curly braces. Let's see the working of while in this program. I'll explain this with the same number that they have given as a sample input 0, that is 10564. So now the n value is 10564. So coming to the while condition, n greater than 0. 10564 is greater than 0. So the compiler gets into the body of the while where they have given sum is equal to sum plus n modulo 10. Here sum initially stores the value 0 in it. So plus n modulo 10, which is nothing but 10564 modulo 10. The remainder will be 4. So 0 plus 4 is equal to 4. Now sum contains the value 4 in it. It comes to the next line, n is equal to n/10, which is nothing but 10564 divided by 10. The quotient will be 1056. The next line, n is equal to n by 10, returns the quotient. Here 10564 divided by 10 returns 1056, which is nothing but 5-digit number is converted into 4-digit. So once we take each digit of a given number, it reduces. The number of digits reduces one by one. To reduce the number of digits, we are using n/10. Now the sum value is 4 and n value is 1056. Now the same process continues. Now it checks whether n value is greater than 0. As 1056 is greater than 0, it comes inside the body of while. Now sum is equal to sum plus n modulo 10, which is nothing but 4 plus 1056 modulo 10, which gives 10 as the output. Now sum has 10 value. Now n is equal to n by 10, which is nothing but 1056 by 10, which gives 105 as the output. So now sum contains 10 and n contains 105. Same process continues. Now n condition is checked, that is n greater than 0, 105 greater than 0, the condition is true. The compiler comes inside the while body. Now sum is equal to sum plus n modulo 10. Sum contains the value 10. 10 plus 105 modulo 10, which gives 15. So now the sum is 15 and n is nothing but n by 10, which is nothing but 105 by 10. It gives the value 10. So sum stores the value 15 and n stores the value 10. Now the n value is 10. Again the condition is checked whether n is greater than 0, that is 10 is greater than 0. Sum is equal to sum plus n modulo 10. Sum has the value 15 in it. So 15 plus 10 modulo 10. 10 modulo 10, we get the remainder 0. So 15 plus 0 is 15. Now sum contains the same value 15. Next it comes to n value. N is equal to n by 10, which is nothing but 10 by 10. The quotient will be 1. Now the n value is 1. Now the condition is checked. N is greater than 0. That is 1 greater than 0. The condition becomes true. And the compiler comes inside the body of while. Sum is equal to sum plus n modulo 10, which is nothing but 15 plus 1 modulo 10. 1 modulo 10 is 1. So 15 plus 1 is equal to 16. Now sum contains the value 16 in it. N is equal to n by 10. That is 1 by 10. We get the value, a decimal value, that is 0.1. As we have declared earlier, the value should be an integer type. We should take only the whole number part and not the decimal part. So the compiler takes only 0 as the n value and not 0.1. So n contains the value 0 in it now. Now again the condition is checked, n greater than 0. But as n takes the value 0, 0 greater than 0 becomes false. So the compiler comes out of the while loop, that is a statement immediately after the body of while. That's all about while loop. Finally, the code has been executed successfully and we have received a message that congratulations, you have passed the sample test cases. Click the submit button to run your code against all the test cases. Here comes the test cases. Let's have a glance at them. Trust you found the presentation good. Thank you judges and all for listening to me.